Hello minions, welcome back to Nick Does Maths. We are going to do an integral here, but we're going to have to be super duper careful and really think about what we're doing. Voici the integral. We need to show that the integral from 0 to pi over 4 of 1 over x minus sine 2x is equal to ln pi root 2 over something. We need to find that something, basically do the integral. Now, why is this of interest to me? Well, these limits 0 and pi over 4. 1 over 0 is undefined. Roll. And we know the integral 1 over x at 0 does blow up. But we've also got something else going on here. We've got sine 2x over 1 minus cos 2x. Okay. And that's another issue because at 0, cos of 0 is 1, so I end up with 1 minus 1, which is 0. I end up with sine of 0, which is 0. So I've got a 1 over 0, a 0 over 0, and generally 0 is a bad place to be. So what are we going to do? Well, we are going to do our normal thing for improper limits like this, is we're going to replace it with a, which in my case is going to be very confusing because my o's and my a's don't differ that much. Right, could be worth also splitting this up just a little bit. And in fact, what I'm going to do is I'm going to write it as plus, and again, What do I want that? No, do you know what? I am perfectly happy with a minus here. Right, now, why have I split it up? Well, in fact, because if I multiply that by 2 and divide by 2, what do I now have? If you differentiate 1 minus cos 2x, you will get 2 sine 2x. So I've got my integral of f dashed over f, which will give me ln of f. Lots of words, have a think. So this is something we can do. So overall, what do we end up with? We end up with ln x. Okay. Minus 1/2 ln of 1 minus cos 2x. Okay. Now, we haven't done the limits yet. Now, the reason is I can do something with these lns, because that is ln of x over square root 1 minus cos 2x, which is pi over 4 and a, which gives me, right, let's put pi over 4 in. Pi over 4 on top. What's cos of 2 pi over 4? Cos of pi over 2 is 0, so we end up with root 1. So that is just ln pi over 2 minus ln of a over square root 1 minus cos 2x. And that, of course, is pi over 4. Now, this is my problem here. Cos 2a. This is my problem. Why is this my problem? Because as a goes to 0, I end up with 0 over 0. Now, a 0 over 0 limit, I've got a few different ways I could do it. We could have a crack at L'Hopital's rule, but a square root 1 minus cos 2a does not fill me with joy. Does not fill me with joy at all. However, it's only cos 2a, right? A is, I know what a does as you get close to 0. A is a fairly easy function. 1 minus cos 2a. But how about, my suggestion is going to be, what if we use, of course, our small angle approximation? All right, which is just the first two terms of our Maclaurin series or Taylor series or whatever you want to call it. Okay, so if we have cos 2a, that is approximately 1 minus 2a all squared over 2, which is 1 minus 2a squared. So 1 minus cos 2a is just 2a squared. If a is small, and in our case it is. So as we take a going to 0, what does this become? This becomes ln of pi over 4 minus ln of a over square root of 2a squared. And the more eagle-eyed amongst you will realize that that just becomes ln pi over 4 minus ln of 1 over root 2. So in fact, this becomes ln pi root 2 over 4. And we're only going to get this by being super careful about our limit here at 0. So putting in a and then taking our limit as a goes to 0. All right? And don't overthink it. Trust me, I did try. I did try and do L'Hopital's rule on that. You don't want to do that. You don't want to do that. Okay? But another good one, as a goes to 0, is to just try out maybe one of your expansions that we know quite well. Awesome. If you thought that was interesting, even if you didn't, but you just enjoy watching me say strange words, please like, subscribe, hit the bell for notifications so you know that this is coming. Like the video, hit like, subscribe. Yes, I said that already, but please do it twice. Like the video twice, or does that unlike it? I don't know. Panic. Either way, I am Nick. I have done some maths here at Nick Does Maths. Please join me again for our next video coming soon. In the meantime, have fun, do some maths. See you then.